Assalamu alaikum student. I'm your physics teacher from IVS school. So let's start a new topic, that is nature of light and electromagnetic spectrum. So first we discuss, I'd like to share some instruction that take a screenshots of every slide that will be shared, and you must have textbooks in front of you and do your all work in your fair copies. So today we start a chapter that is about nature of light and electromagnetic spectrum. And the topics are quantum theory of light and dual nature of light and spectrum. So first we know that what is light. Light is a form of energy and life on the earth without it would not have exist. We also know that it can travel through empty space and move faster than anything else. So many researchers through the ages have been taken up the challenge of finding out that what is light and how it behaves. The fact is that light exhibit behavior that are characteristics of both waves and particles. In this chapter, we will study that who proposed that what is light and how it behaves. So, the first scientist about that theory is Max Planck. Max Planck in 1905 proposed that light is emitted and absorbed in the form of tiny packets of energy, which is known as quantum. So, when the Max Planck studied the radiation of the hot object it emits, it proposed that the light emit in the form of a packets which is known as quantum. So, if packets of energy are discrete, they must have some minimum size for one of these packets, and that packet is called a quantum. So I hope you will understand that what Max Planck proposed. What Max Planck proposed that light is emitted and absorbed in the form of tiny packets of energy, and that packets of energy, according to him, is known as quantum. And the other scientists, which also relate to that theory, and that scientist is known as the Einstein. Einstein is called the greatest physicist of the 20th century because of the groundbreaking research result announced in 1905 that had a great impact on physics. These research papers were on the photoelectric effect theory, where light is made up of particles called photons. So Einstein was the one who discussed that light emit in the form of waves as well as in the form of particles. He recognized that Planck's discrete packets of energy could explain the photoelectric effect. Einstein called the quanta. He gave a new name, and that is known as photons. Photons are the smallest particle of which the light is made. Or we can say that as we have smallest particle of the matter is electron, proton, and neutron. So similarly, according to the Einstein, the smallest particle of the light is known as a photon. Before Einstein, only the wave nature of light was recognized. Okay, I hope you will understand that what is the work of Einstein. Einstein proposed that the light behave in the form of waves as well as in the form of particles, and that particles he gave a new name for these particles, and which is known as photons. But the photons of the Einstein are not a material particle such as balls. They can behave as waves. Therefore, according to Einstein theory, light along with the other electromagnetic radiations has a dual nature of light. That is, it acts as a particle as well as the wave. Now you will understand that what Einstein proposed. Einstein proposed that light exhibit dual nature of light. It behave like a waves as well as it behave like a particle. So what is quantum physics? Quantum physics is the theory, quantum theory of light is the theory relating to light propagation and generation. Max Planck in 1905 propose that light is emitted and absorbed in the form of tiny packets of energy, and that packets of energy is known as quantum. As you can see in the slides, that light is thought to consist of a tiny bits of energy that behave like particles called photons. We have discussed it. What is photons? Photons are the massless particles, or we can say that it is the basic unit of light. Particles explain how light travel in a straight line or reflect off a mirror, as the reflection is occur in a waves, or we can say that reflections occur in a sound. Similarly, reflection is also occur in a wave. Now, the particles behave like the reflections occur in a mirror. Quantum theory describes that light consists of a minute particle that have properties of waves. This is very important term, that quantum theory describes that matter and light consist of a minute particles, and that particles are known as photons that have the properties of waves. This is very important thing, that the particles are behave like the waves that are associated with them. So light consists of the particle known as photons, and matters are made up of the particle known as protons, electrons, and neutrons. And why it is happen that these particles are behave like a wave? Because the mass of the photons are very less, or we can say that it is almost a massless particle. That's why we can say that it behave like a wave. So electromagnetic energy travel in the waves. The waves are different from each other in their lengths, called the wavelength. As we have discussed it, what is wavelength? Wavelength is the distance between the two consecutive thrusts and the distance between the two consecutive troughs. And how we measure wavelength? What will be the unit of the wavelength? Wavelength, the unit of the wavelength is meter, millimeters, nanometers. As we have discussed, that it is a length, so it is a distance. So the distance of a unit is meter, and that's why again the unit of a wavelength is meter. But when we are talking about the light, wavelength of light, so we consider their wavelengths in the nanometers or micrometer because they are very small. Okay, now when we are moving toward the next topic, that is dual nature of light. As I told you that the light exhibit both type of nature, that sometime it behave like a particle and sometime it behave like a wave. So we must know that how it behave like a wave and what are the phenomena which are related to prove that light is behave like a particle, and what are the phenomena which prove that light is behave like a wave. So here we will consider that sometime the light behave like a particle. And how we can say that light behave like a particle? Because scientists have performed an experiment which is known as photoelectric effect. And according to that photoelectric effect, we can say that an important feature of this experiment is that the electron is emitted from the metal with a specific kinetic energy. When these metals absorb electromagnetic radiations, so the effect is defined as the ejection of electron from a metal plate when light falls on it. So this is the phenomena of photoelectric effect, that when the light is falls on the metallic plate, it exhibit electrons. Okay, I hope you understand that. As we know that the metals have a free electrons in their outermost orbit. So when the light strike on the metal surface, so that metal surface emit electrons. So that's why we can say the effect is defined as the ejection of electron from a metal plate when the light falls on it. So this is the description of the photoelectric effect. And now let me discuss that how light behave like a wave. So as we have discussed the sound waves in our previous chapters. So we have discussed that sound waves are reflect and refract. So in a similar way, light is also reflect and light is also refract as the waves do. It's mean when as the waves reflect, so light also reflect in the same manner that any waves would reflect, and light refract in the same manner that any waves would refract. Do you know the difference between the reflection and refraction? Reflection means the bouncing back of light, and refraction means when the light strike on the one medium, enter into a one medium and strike on the surface of another medium. So part of it will bend. So in this phenomena are also described by the light. And that's why we say that light refract in the same manner that any waves would refract. Now light also undergoes interference, diffraction like all waves do. Interference means superposition of the waves. And the bending of light can also explain due to the on the basis of the wave propagation. So that's why scientists agree with the idea that light behaves like a waves. So that's how you can understand that what how we can say that the dual nature of light is exists, because there are many ideas which support that light exhibit in the form of a particle that is known as photons, and it behave also like a waves, that it have all that it uh, determine all the behavior of waves as the waves. Like for example, light can reflect, light can refract, and light can do interference and bending of the light. So as you can see that in a diagram, that we have two types of description. In a first diagram, you can see that we have a light source, and from these light source, the energy brackets are emitted, and they all are in a sequence way. The first thing which the scientists uh, suggest that, and all the scientists are agree with that opinion, that these energy brackets are move in the form of the wave. As you can see that they all are in a arranged manner, or in one by one they will arrange themselves. So if we place any barrier in front of the light, so these particles cannot cross that barrier, and the shadow is formed on the either side of that barrier. Okay, and that's how we can say that the light in the form of particles exhibit light in the form of particles form a shadows. Now the waves bend into the shadows. Here the lights, here we show that lights it emit in the form of waves. And if we place any barrier in the on the way of light, so the light is bent at that part. And this show that light bent like the waves bent when the barrier comes on the way of light. So that's how we can show that light has a dual nature. It can move in the form of particle as well as it can move in the form of waves. And now, to understand the basic unit of light, that is photon, we must have to understand that light is emitted or absorbed in a small bundles of energy called photons. Okay, I repeat, light is emitted or absorbed in small bundles of energy called photons, which travel in a straight line. This is very important thing, as we have also shown on the previous diagram, that these particles are travel in a straight lines by a wave-like motion. As waves are moving in a straight line, so similarly, these particles are also move in a straight lines. So light is emitted or absorbed in a small bundles of energy called photons, which travel in a straight line. And photons carry fixed amount of energy but have no mass. This is also a very important point that these photons are the massless particles. So energy of photons is depend on the frequency. And on what frequency? Frequency of the light. The shorter the wavelength and the greater the frequency. And again, it's an important point that if the wavelength is short, so it's mean its number of waves are increasing in a unit time. If the light have a shorter wavelength, so its number of waves are increased in a second. And due to that increase of the number of waves, frequency is also increased. So that's why we can see that the shorter the wavelength, the greater the frequency and the higher the energy. Energy is also have a direct relation with the frequency. So do remember it that the relation of the wavelength and frequency are inversely proportional and the relation between the frequency and the energy is directly proportional. So if the wavelength is short, it has a greater frequency and it as well as it has a greater energy. So do remember it that the lights which have a shorter wavelength have greater frequency and higher energy. For example, a photon of a violet light has frequency which is greater than the frequency of photons of a red light. How it possible? And similarly, the radio waves are as long as a soccer field, low frequency, low energy. And the gamma rays are smaller than an atom, so it has high frequency and high energy. So now you can easily understand that how the photons of the energy are related with the wavelength. I repeat, a photons of the violet light has frequency which is greater. And why it has a greater frequency? Because the wavelength of the violet light is less. And the how we can say that frequency of the photon of red light is greater because it wavelength is greater. Now the radio waves are as long as the soccer field and low frequency, low energy. As we know that the radio waves has a greater wavelength. Due to the greater wavelength, it has low frequency and low energy. And gamma rays have a low wavelength, means a very small wavelength, and that's why it has high frequency and high energy. So photon is depend upon the energy of the photon is depend upon the wavelengths and frequencies. I hope you will understand and we will move toward the next topic that is photoelectric effect. So how do we believe that light consists of the particle known as photons? This idea was supported by the well-known experiment which is known as photoelectric effect. As we know that the metal have free electrons on their outermost shell. So when the light strikes on that metal, it emits electron. Light is shown on a metal and after certain binding energy is overcome, an electrons is emitted from the metal. As you can see that here is the metal and it has many free electrons because all the atoms has free electron on their outermost shell, and that's why the metal has a large range of free electrons. And when the light is strike on that metal, so it emit that electron to the outer side. So an important feature of this experiment is that the electron is emitted from the metal with a specific kinetic energy. It's the energy of that electron is also very high. When these metals absorb electromagnetic radiation, the effect is defined as the ejection of electron from a metal plate when light falls on it. I hope you will understand that what is photoelectric effect. As you can see that we have a metals and due to the atomic structure of the metal, we have free electrons on their outermost shell, and due to these free electrons on their outermost shell, when the light falls on that metal plate, it emits electrons. So take a screenshot and we will move toward the next slide. spectrum. To understand the spectrum, we must understand that what is dispersion. So the phenomena of the white light into its color, the phenomena of the splitting of a white light into its color is called the dispersion. As we know, the white light of the sunlight is composed of 7 colors. So when we split that white light into its 7 colors, this phenomena is known as dispersion. And what is a spectrum? The band of 7 colors, which is formed as a result of dispersion. So that phenomena is known as a that band of color is known as the spectrum. I repeat that what is a spectrum? Due to the dispersion, the band of 7 colors is formed, and that band of 7 colors is known as the spectrum. Okay, so there is a little difference between these two terms, dispersion and spectrum. Dispersion is this phenomena in which we split white light into its 7 colors, and that splitting is known as the dispersion. And how we can split the white light? We can split the white light through the prism. And what is prism? Prism is a triangular shaped glass which we place in front of the sunlight, so it break the white light into its 7 colors. And the band of 7 colors which is obtained due to the dispersion is known as the spectrum. Okay, so here we are moving toward the for the further understanding of the spectrum, that here is the prism, that is the triangular shaped glass, and when we place in front of the white light, as you can see that here the white light is coming and strike on the one side of the prism. So what will happen? It will emit out from the either side of the glass, of the either side of the prism, and when it emerge out from either side of the prism, and we place any screen in front of that prism, so we get a 7 colors. A band of 7 color can be very clearly seen. So when that is how prism split the light. Now, to understand that how the prism split the white light into its 7 color, we have to understand that white light is composed of different wavelength. White light is composed of different wavelength. Means white light is the combination of many wavelength. And when this white light is enter into the prism, it prism deviate all the wavelength in a different angle. And why it deviate all the wavelength in a different angle? Because the angle of deviation is depend upon the wavelength. As you can see that violet light is deviate more, and then as we are moving from the violet to the red light, indigo, blue, green, yellow, orange, they both have different wavelength, and violet light have a smaller wavelength and indigo has a slightly greater wavelength than the violet, and blue has again slightly greater, means violet, when we are moved from the violet light to the red light, so gradually the wavelength is increasing, and the red light have a maximum wavelength. So that's why red light do not deviate at a greater angle. It is less deviate. Why it is less deviate? Because it has a greater wavelength. That's why it deviate less. And the violet light have a have a smaller wavelength, and that's why it deviate greater amount. So that's how now you can understand that prism deviate the white light according to their wavelength. So to understand further, for the further understanding, we will use that diagrams, that as you can see that violet light have a wavelength 380 nanometers to 450, and gradually the wavelength are increasing. If you can see that blue have 450 to 490, green have 495 to 570, and the yellow have 570 to 590 nanometer, and the red has 620 to 750. So the wavelength of red light is have a greater or a maximum wavelength, and the violet light have a most smaller wavelength. As you can see in this diagram, we can show that violet light has a smaller wavelength, and when we are moving toward the red color, the wavelength are gradually increasing. So that is the reason that when the white light is entering into the prism, so it deviate violet light with a greater amount because it has a smaller wavelength and higher frequency. Okay. As I told you that wavelength and frequency are inversely related with each other, inversely proportional. If the wavelength is less, so it has a higher frequency. And the red light, it has a greater wavelength. So its angle of deviation is less. Okay, it's depend upon the wavelength. If it has greater wavelength, so it deviates with a less amount. So that's why prism deviate all the seven colors according to their wavelength, and their wavelengths of the seven colors are different with each other. So that's why our eyes and our brain interpret this wavelength according to their colors, and that's why we see the spectrum on the screen when we place the prism in front of a white light or a sunlight. So here you can see that the light red, orange, and yellow have a longer wavelength, so it has low frequency. And you can see that the green, blue, indigo, and violet light had a shorter wavelength and it has a high frequency. As I told you, that frequency and wavelength are inversely proportional. Frequency and wavelength are inversely proportional. So you can see clearly that a light have a long wavelength, least readily scattered part of the spectrum, and most readily scattered part of the spectrum are green, blue, indigo and violet. So take a screenshot of that slide. It will help you to further understanding of how we get a spectrum through the prism and what is the working of the prism. And now when we are moving toward the next topic, and that topic is electromagnetic spectrum. So students, do remember that the spectrum which we have discussed earlier, that is the visible spectrum. And now the electromagnetic spectrum is not visible. And why it is not visible? Because it has a very large range of wavelength which cannot be seen by our eyes, as well as it has a very small wavelength which can also be we cannot see by our eyes. So electromagnetic waves are the waves that are capable of traveling through a vacuum. So do remember it that like the waves, when we are talking about the sound waves, so we cannot hear the sounds which are coming from the sun. And why we cannot hear it? Because sound cannot travel in a vacuum, but light can travel in a vacuum. As the light from the sun come to the earth, and we have a vacuum in between them. So we can say that electromagnetic waves are the waves that are capable of traveling through a vacuum. Electromagnetic waves are capable of transporting energy through the vacuum of outer space. So electromagnetic space, so I hope you will understand that what are electromagnetic spectrum. Or we can say that light carry information in many ways. Cell phones use light to send and receive calls, messages, and car radio use light to receive music from radio stations. So how these messages are transferred by light? It all can happen due to the presence of electromagnetic radiation in light. Means electromagnetic radiations or electromagnetic spectrum are very useful, and when we combine when we make a group of these useful radiations, so that is known as electromagnetic spectrum. I hope you will understand that what is electromagnetic spectrum. And now when we move further, electromagnetic waves are produced by a vibration of electric charge, and as such they consist of both an electric and magnetic component. So by the name of the electromagnetic waves, you can analyze that these waves are formed due to the electricity and magnetism behavior. So we will later we will discuss in detail that how the electric charge and magnetic component are responsible for the generation of electromagnetic waves. Electromagnetic waves exist with an enormous range of frequencies. As I told you that it has this type of spectrum has a greater wavelength as well as it has a shorter wavelength. So similarly, we can see that it has a range of frequencies, enormous range of frequencies, because we know that wavelength and frequency are inversely related with each other. So here is the some detail that electromagnetic waves are grouped into types that have similar wavelength and so have similar properties. So radio waves, as you can see, that radio waves can be the wavelength of radio waves can be measured by up to 100 meters. It is just like a soccer field. All it we can say that radio waves have a large variety of waves. So uh, radio waves has a very longer wavelength. On the one end of the spectrum of the radio waves, which have wavelength billions of times longer than those of visible light, that is from several meters. And on the other end of the spectrum are the gamma rays. As you can see here, we have gamma rays, and gamma rays has a very shorter wavelength. As you can see there, it is 0.01 nanometer. Okay. So when we are moving from the radio waves to the gamma rays, the wavelength is gradually decreasing. So the radio waves has a greater wavelength and as well as the wavelength is greater, so it has low frequency. And the gamma rays have a smaller wavelength. So due to the smaller wavelength, it has high frequency. Okay, all the wavelengths are discussed here. So now we are moving toward the further understanding of these waves, that how these waves are behave like are useful for us. And do remember that these waves are useful for us and as well as it is also dangerous for us. So as you can see that the radio waves, so radio waves are just look are like a buildings. Okay, so do remember it. Use of electromagnetic spectrum. Radio waves, your radio capture radio waves emitted by a radio station, bringing your favorite tunes. Radio waves are also emitted by the stars and gases in the space. And microwaves are the radiation will cook your popcorn in just a few minutes. Means microwaves are waves which are used in our microwaves oven and which is used to cook the food. But it also used by astronomers to learn about the structure of nearby galaxies. Okay, it is also helpful for the astronomers to learn about the structure of nearby galaxies. So this is the use of radio waves and microwaves. And now we discuss all types of waves, all types of waves gradually. So here is the waves of electromagnetic spectrum. As we have discussed that radio waves are electromagnetic waves with a large range of wavelength from few millimeters to several meters. So again there is a microwaves and microwaves are radio waves with shorter wavelength between 1 millimeter to 300 millimeter. Okay, do remember the wavelength of all types of waves because it is very necessary to remember it. It is very important. Microwaves are radio waves with shorter wavelength between 1 millimeter to 300 millimeters. Microwaves are used in radar and microwaves ovens. Okay, as we have discussed that microwaves are used for the astronomers to study about the nearby galaxies, and as well as these microwaves are also used in the radars to transmit message. Infrared waves. Infrared waves are also called heat waves. These waves are radiated by the hot body at a different temperatures. The Earth's atmosphere at a mean temperature of 250 kilo radiates infrared waves with a wavelength having a mean value of 10 micrometer. So again, infrared waves are the waves which are radiated by the hot bodies at a different temperatures. And now the visible waves. Visible waves have a wavelength range between 400 nanometer and 700 nanometers. Now, as you can see that when we are moving from the radio waves to the gamma waves, so gradually the wavelengths are decreasing, and the radio waves have a wavelength in meter, and now we are come toward the nanometers and millimeters. So visible waves have a wavelength range between 400 nanometer and 700 nanometer. The peak of solar radiation is at a wavelength of about 550 nanometers. The human eye is most sensitive to this wavelength. As I told you that these wavelengths are very useful for us for sending a messages, and as well as it is also harmful for us. Ultraviolet waves. The wavelength of ultraviolet waves range from 380 nanometer down to 600 nanometers. These are emitted by hotter stars having a mean temperature greater than 25,000 degrees centigrade. There is also a ray in between them and which is known as X-rays. X-rays range from 1.0 nanometer to 0.01 nanometer. Gamma rays wavelength is less than 10 raised to power minus 11 meters. They are emitted by the nucleus of certain radioactive substance. They are also released during certain nuclear reaction. These wavelength ranges are not exact and the values given here are only for a general guideline. So do remember it, student, that the wavelength ranges are not exact and these are the values given here are only for the general guideline. Okay, so I think you will remember it that how these values of the wavelength we have given you are just a general idea to show you that how the wavelengths of uh, different waves are increase or decrease and how the frequency is related to these wavelengths. Okay, now we will move toward the now we are moving toward the home task, and home task is define photon and spectrum. You have to write the definition about photons in spectrum, discuss dual nature of light in terms of quantum theory. You can also write down answers of these questions from the book or from the summary. The definition, you can find definitions from the summary, and you can find the discussions or the explanation about the topic from the book. Discuss electromagnetic spectrum means you have to write all the ways which are related in a electromagnetic spectrum, and do remember yet you also have to write about their wavelengths of the electromagnetic spectrum. So I hope you will understand it, and it is all from my side, and Allah Hafiz.